Guys, welcome to Cisco with Amansoni, and in this video we are going to talk about the spanning tree algorithm and various port roles and port states that will happen when the STP algorithm is run. So in my previous lecture of spanning tree protocol, we talked about why do we need spanning tree and what would happen if spanning tree algorithm is not running. So if STP is not running, if you remember, that loop will happen in your switching topology. So how spanning tree will stop the loop? Spanning tree protocol is already running and spanning tree will put some ports into the blocking states. Yes, the other topic for today, spanning tree various port roles. Port roles I haven't talked about, but I told you in the previous video port states, forwarding and blocking. If you haven't watched the previous video, I strongly encourage you to watch that because that video will describe the very extreme basics of spanning tree protocol. I will put the link of that video in the description. This is actually a third lecture of the Cisco switching series, in which the very first video I covered about the basics of a switch. What is the job of switch, how it works, how it learn MAC address and how it send data. In the second video I talked about the basics of spanning tree, what is spanning tree, why do we need it. In the third video today we are going to study the algorithm. So without further delay, let's hop into the GNS, because I really like to teach the things, the topics, the protocols and all via the lab, because then you can really see how it really works, because the theory and topic and points and notes you can study via online thing. So let's take some switch, and also this is GNS, so please go ahead and watch the video to how to set up GNS and how to set up the GNS the switches in the GNS3 as well, because by default if you install GNS3 you will not get these switch, you will get this Ethernet switch, but Ethernet switch we cannot do much. Why? Let me just show you right here. I will click here and all the devices are turned on now, they are up. And if we see, these are the switches that I configure via the VMware. So right click and console, and you will see that the console of IU1, that is switch 1, will come up. But for the default switch present in GNS3 you cannot take the console. Command line is there, but give you just in normal warning that you cannot take the CLI. Okay, so on these switches only we can perform the lab. We will just do some connectivity here and we will see that how it works, how the spanning tree algorithm will run, how it will put some ports into forwarding and some ports into blocks. So what is the very first job for spanning tree? See, in order to completely understand the algorithm, there are few terminology. I will just write here a lot of terms that you need to know in order to completely understand spanning tree. And by spanning tree, I am actually talking about the classical spanning tree. Because see, spanning tree has a lot of different flavors or variants. We are talking about classical spanning tree. There is per VLAN spanning tree, MSTP, RSTP, and a lot of stuff. PVST, RSTP, MSTP, but we are concerned about the basics classical spanning tree, which has the IEEE code of 802.1d. So what is our topic today? It is actually how the algorithm works in 802.1d to stop the loops. So some terms like what is a root bridge, what is a bridge ID. It's a very important parameter on which the algorithm works. You will just see in the following section. So bridge ID is there, then a lot of port roles. What kind of port roles? We have a root port, we have a designated port, we have an alternate port also simply, or I can just call that port blocking port, that you already know. Okay, see, blocking port in this sense you can say it is alternate or blocking also. Okay, why? Because blocking port is actually a port state. Okay, so root port and these, all these are three are port roles. Let me show you here. I have a notepad created for you so that you can further understand. What are the various port role in STP? The port can be a designated port, it can be a root port, or it can be alternate port. The designated port and the root port are always in the forwarding state. In my previous video, the basics of STP, I told you that STP will put some ports into forwarding. Yes, perfectly correct. and some into blocking. But into the forwarding also, some ports will be designated port and some port will be root port in our topology. So just remember one thing: whenever a port is forwarding, it means it can always send and receive data, and the blocking port can never send neither receive any sort of data. But what it can receive and process, it can receive incoming BPDU. What is BPDU? BPDU means bridge protocol data unit. It's a, just like you can consider it as a hello packet that switches send between each other to just follow the some parameters that are needed in spanning tree. Okay, to share their parameters. What kind of parameters? Like their MAC address, like their bridge ID, all these things, priorities, and lot of stuff that are needed for spanning tree algorithm. All of those things are inside the BPTU. Okay, so these are the terms that you have to know. So let's start with the very first. What is a root bridge? Let me show you here. This is a root bridge. So consider, see, spanning tree protocol is just like this. That's why we call it spanning tree. Lot of switches are there, they have a lot of connections. And what it will do, it will span the tree so that some ports will be blocked. Why? Because after applying spanning tree protocol, you cannot have redundant connections anywhere. So that is the job. So it will span like a tree, and the tree spanning will start from the root. So that's why the most important switch of your spanning tree topology is known as the root bridge. It is the main switch or the king switch, you can say. The technical term is root bridge. So in our switching topology, when STP is running, the very first thing, a root bridge is elected. So how to elect the root bridge? How to tell that, okay, we have three switches, and yes, if we connect them, then one of them is going to be root bridge. So how it is decided? It is decided on the basis of bridge ID. The switch which is having the least bridge ID will become the root bridge. So what is this bridge ID? So the very first term we are done with, we know what is a root bridge. The main switch, the best switch of the topology which is having the least bridge ID. So question number 2, what is bridge ID? So bridge ID, my friends, is nothing special, but it is a combination of the priority and the MAC address. Okay, so this is like, these two things are not added, they are just written like that. What is the priority of your switch, and dot, and what is the MAC address of the switch? So let me tell you, priority, don't worry about it much. Yes, if you want, you can change it, give it manually, but for now just always remember the default priority is 32768 of all your switches by default. It is just the default priority. For example, if you might, the lot of other protocols are there also in routing. On routers, if you do HSRP, in HSRP also the default priority is 100. If you don't know HSRP, don't worry, it is just some other protocol. What I want to tell you, that a lot of protocols are there which use some default priority or some default parameters, and in spanning tree we have a default priority set. If you want, you can go in there and you can change it also. Default priority 32768. What about the MAC address? Yes, MAC address, we already know it is a 48 bit, or I can say it is a 6 byte. Okay, the MAC address is a 6 byte field. It is a physical address. It has 12 characters. Example, it looks something like this: 12 hexadecimal characters. Every switch has a base MAC address, because sometimes people doubt that if I click here, a lot of ports are there and each of them will be having their own some unique MAC address. So how I can decide the bridge ID? Because the bridge ID is not of any port, the bridge ID is of the whole switch. So the question is, which MAC address you are going to use? The question is none of them. We are not going to use any MAC address. We are going to use base Ethernet MAC address. It is like this. So the base MAC address of IU1 will be put here, and this thing will become the bridge ID. Same for switch 3 and same for switch 2. The question is, how can you see the bridge ID? So fear not, I'll tell you. We already have the console. How to take the console? Just right click, start every device. We have already done that. Double click, you'll get the console if everything is right. Then show version. Okay, this you have to do.
and then you might see the MAC address. See, but the thing is, on some switches it might not be here. So see, fear not. What I will do, one other command is there at our disposal. I can do show spanning tree. Okay, most of the time it will show you here, but for some reason, if it is not there, fear not, just do the show spanning tree and it will tell you something. It will say root bridge. Root ID means root bridge ID. Okay, so he's saying this is the MAC address of the root. This is the MAC address of the main root bridge. And in here it will say my own details. So always remember, when you do show spanning tree, this section is of the root bridge, the main switch, and this section is of his own. So if you look at them, look at it carefully, you will see the priority 32769, priority 32769, the MAC address is same, MAC address is same, everything is same. It is actually, this switch is saying that right now I am the root bridge. I am the best. Why? Because he is not connected with any other switch. And one thing you might be arguing with me, that the priority I told you is 32768, but in here you can clearly see the priority is 32769. Okay, it's not like that I'm making some mistake or I am just fooling you or like something like that. Always remember the default priority is 32768, but when it is used by the spanning tree protocol, another parameter is added into this priority, and that parameter is known as extended system ID. Okay, that's why I just want to leave it out of this. It is nothing special, it is just the VLAN ID. What is a VLAN? A VLAN is nothing special but the broadcast domain or the logical boundary to which that port belongs, and by default all these ports on a switch are in one logical boundary, or in technical terms I can say all ports of a switch by default belongs to VLAN 1. So that's why this VLAN 1 is actually the VLAN ID to which that port belongs is the extended system ID. So what you will do, 32768 plus 1, it becomes 32769. And just to prove this thing, just read it carefully. You can see that my priority is 32768 and the extended system ID is 1. That's why you'll just add them. Priority will become 32769. And the MAC address is same of the root bridge and his own. Why? Because right now he is thinking that I am the king. I am the root bridge. Okay, root bridge is just king. So he's saying that I am the king right now. So let's just copy this MAC address and let's put it here. And also, just for clarification, let's make it 9, but always remember default priority is 32768. Okay, it's like this. Let's go to switch 2. Let's see what he thinks. Show spanning tree. So what he thinks that right now I am the king as well. Every switch in the beginning will think that he is the root bridge because he is not connected with anyone. So default priority plus VLAN ID and the MAC address. Let's go to switch 3. Okay. You double click and you will get the console. Show spanning tree. Just copy the MAC address. Same thing. Who is the king? This guy. Who are you? I am this guy. Pretty much they are saying I am the king. So all of them right now are thinking that they themselves are the king. They are the root bridge. As you can see, the MAC address are different. So the question is how the switch will elect, how the topology, the spanning tree will elect who is the root bridge. The thing is, if you connect them with each other, let's imagine for a moment they're connected, then what will happen? In here you might see the hello time 2 seconds. This is the hello time for bridge protocol data unit, or the BPDU. As soon as you connect, they will send BPDU to each other, and BPDU is a very important thing. In the beginning it's not that big of a deal, but later on in this series I'm going to a single video dedicated to BPDU. How many different types of BPDU are there, what is inside the BPDU, what are the flags and all things. So right now, what is BPDU? It is just like a hello packet which is used between switches to talk between each other so that they can do the spanning tree election. What are the things inside the BPDU? A lot of things. The most important ones are the priority. What is my priority? What is my MAC address? Or in short, this whole thing is known as bridge ID. So every switch will say that my bridge ID is this. So this guy will send the BPDU to switch 3 and switch 2. Let's put it here. Yeah, it looks more good like this, because switch 1, switch 2, switch 3. If you want, you can put it, when you are doing it, you can put it any way you like. Okay, I like to keep things simple, especially in the lectures. So if you connect them, switch 1 will send the BPDU to switch 2 and switch 3. Switch 2 will send it to switch 1 and switch 3, and switch 3 also will send to the both of the guys. Now when receiving the BPDU, what will happen? They will compare and see who has the lowest bridge ID, and then whoever switch is having the least bridge ID will become the king, and his details, the details of the king, will be pasted here. Okay, so the thing is, like, it's a pretty common thing, but students find it confusing that how can we compare the bridge ID. See, it is just so simple. How can you compare these two numbers? Okay, which is the least number? It's super easy. 4, 5, 6 is the least number. Why? Because see, when you compare things, you start comparing from the left side or the right. Obviously from the left, from this side. So I won't say that I'll compare 6 and 7. No, I will compare the 4 and the 8. So 4 is less. That's why this whole thing is less than this 897 value. If it happened to be that we have a 8 here, then what? Pretty simple. I'll compare 8 with 8. Yeah, same thing. Then I'll compare the second digit, 5 and 9. 5 is much less, so this value is still less than this value. Same way you will compare the bridge ID. Okay, you might find this very silly, but believe me, I've been asked this question like hundred of the times in my lectures. That's how to compare the bridge ID. It's super simple. Let's compare with switch 1 and switch 2. For example, he received the BPDU from switch 1. He will say that my priority is 32769, and yes, again you will start comparing from here only. Meaning what? You will compare the whole priority. So you will say, okay, priority is same. Then comes the MAC address. So I will start comparing, see, from one by one, 32769, A, B, B, C, C, all of them, and where the tie will break. You can see up till this point, and up till this point everything is similar. Then will come the 1 and the 3. So which value is less, 1 or 3? 1 is less, so then he will say, okay, that's a bad news, I am not the king anymore. Who is the king? The other switch is the king, because he is having the lowest bridge ID than myself. So I will tell that he is the king. Now same thing will happen here when this guy will receive the BPDU. Then he will compare and he will also say, okay, this part is same, but I have much higher bridge ID than switch 1, and I'm not the king anymore, this guy is the king. So in short, this guy will become the main switch, the king, or technical word for that, he will become the root bridge of the whole topology. And after that, only the root bridge will be sending the BPDUs. The other guys will not send any BPDU. They will just listen. They will just listen. They will listen and forward. Okay. What do you mean by listen and forward? See, think like this. We have a very simple topology. But what if there is one switch here, and see, you have to be in networking, you have to be very imaginative. Okay, so if you're not that imaginative, go and watch some science fiction movies, it will help a lot. And if you're not that much imaginative, don't fear, just keep on doing the works. As soon as you get the concept, more and more imagination will start happening inside your head. So I told you this guy will send the BPDU. He will also send the BPDU here because he is the root bridge, and they will just receive and forward it. Okay, they cannot generate their own BPDU because they are not the king. This guy is the main king. He will be sending the BPDU, and in that BPDU he will say that I am the root bridge and this is the details of root bridge. So if a new switch is connected, immediately he will know that, okay, these are the details of the king, and I will also install them in my spanning tree information. This is the king, I am not the king. Okay, so that's how things work. That's from here. See, this is the root, and from here the tree start growing like this. the branches start growing. And that's why we have the name of spanning tree protocol. So this all was our hypothesis, our imagination. Let's see how it works. We don't need this because we are working on a very simple topology. So as soon as I will connect, okay, you have seen that everyone was saying that they are the main guy. They are the root bridge. As soon as you will connect, go to IOU2. Previously he was saying I am 0030 and I am the king as well. See, root king details. I am the root bridge details. But now if you do show spanning tree, I am not the king anymore. Who is the king? The king is this guy. Okay, all hail the king. AABBCC00O100. And this MAC address belong to switch 1. Okay, it won't say it like this that okay, switch 1 IOU1 is the king. No, this now in spanning tree every switch have the identity with their bridge ID. It's like your employee ID or your roll number in your university. So who is the king? This guy is the king. I am not the king anymore. So these are the details of the king and these are my details. I am 300. I am not the king. Who is the king? The guy with having the priority of 32769 and the MAC address. This 0 at the end and he is IU1. So let's go to switch 3 and he will be saying something similar. Same song he will be singing. Look, I am not the king anymore. Who is the king? The guy with the MAC address 0100 is the king now. He is the root bridge. So that's how the root bridge election happens. Okay, so in this video, okay, I don't want to make a very long videos for you guys. Just go them one by one step at a time. And this whole video, let's dedicate this whole video to the root bridge. How to elect the root bridge? I'll summarize the whole video. Whenever you connect some switches, they all will exchange BPDU. They all will, every switch will say, I am the king, I am the root bridge. But very soon, the guy with having the lowest bridge ID will become the king. What is bridge ID? Nothing special, nothing fancy, just a combination of your priority and your MAC address. Okay, so it's quite okay. And some of you might be thinking very good and they might ask, what if the bridge ID are same? That's a very good question. Half of you smart people might be thinking, how the hell can the bridge ID can be same? Because the bridge ID consists of the MAC addresses and the MAC addresses are always and always unique. So you might say the bridge ID can never tie. Right, it's a very good thing. The bridge ID should not tie because the MAC address are unique. So if MAC addresses are unique, then the bridge IDs are unique. Very good. But there are some special cases in which the bridge ID can also tie. Okay, so you might be scratching your head. Don't do that. I'm here for that. Okay, not for scratching your head, but for telling you how to solve this issue. Okay. So imagine, just leave that thing. Just imagine this scenario. We have only one link, and for the moment, let's think this guy is the root bridge. Or leave the root bridge. He will be sending the BPDU. And what will happen if you connect it here? Then your bridge ID from both sides will be tying. Okay, so this is a very special case. Okay, so all these advanced stuff we will do in the later parts. Okay, we are still continuing. We are not over with the STP election. If something like this happen, then both BPDU coming from this link and coming from this link having the bridge ID of this thing. So in STP algorithm later on you will see that this thing might cause issues. But fear not, you don't have to do a single thing. STP have its own mechanism to deal with things like this. So that was little advanced. For the basic one, connect the switches. The switch with the lowest bridge ID will become the root bridge. Okay, so this was your step, actually step number 1. I'll just put here algorithm steps. Algorithm, the spelling I have to correct. The very first step, select the root bridge. The second thing we'll see in the second video. Okay, I don't want to give you any spoiler for that. There are few process. After that, it is over. Every port will be having its own port role. Some of them will be becoming root port, DP, and alternate also. So this whole video was dedicated for spanning tree, root bridge, and bridge ID. Next video will continue with the same algorithm. So please like the video, share your feedback, and if you haven't subscribed yet, click on that subscribe button. It really motivates me to make such video for you guys. So Aman Soni signing out for now.